Sorry. So thank you for being here and listen to my talk. Like I'm introduced, I'm an ecotoxicologist. These are people who are interested in chemicals in the environment, how they move around and what the effects are. So that's where my chemicals are coming from. My interest in bees started when I was a teenager and I was volunteering at the zoo in Amsterdam in the insect house, and the manager asked, like, do you want to have a look at my bees? And we had like one of these display hives so people could have a look how they were behaving, but we also had some backup hives on the top of the roof, and I was not so keen. Like, things you learn, bees sting and you stay away. But I was scared to say no, so up I went up the roof and I tried to stay as far as possible, but they said, no, you have to help us. And actually when I had a look in the hive, it was fascinating to see how these bees were working together to a common goal, so I got really interested in bees. So that was almost the end of my beekeeping career. I have to admit it was really short. I had to go for a research project at another city in the Netherlands. And in the Netherlands, bees are not allowed in a train, so I had to leave them behind. So that's enough about me. I'm here to talk about the EPA and about the work what we're doing to protect the environment when hazardous chemicals come in. So these decisions that the EPA makes impact the everyday life of New Zealanders. Think about the strawberries you might have in the hotel for your breakfast. They're not fumigated with methyl bromide anymore, and that was a decision made by the decision makers. Think about the toothpaste you used in this morning. It's actually a hazardous substance, so it's managed by the EPA. Petrol in your car. But besides thinking about chemicals, the EPA also manages the emission trading scheme, so those are the carbon credits of New Zealand, and the zoo animals, which are new animals for New Zealand, and biocontrol agents, for example, for the giant willow aphid, if that ever comes. And we also work as far as in the sea in the exclusive economic zone. So the focus of this presentation will be about chemicals, and the particular focus will be about chemicals and bees. So I will talk to you about what we do before a substance hits the shelves. I will talk about what we do when it is available, and at the end I would like to ask your help to make sure that we have the right information to make the right decisions. So the role of chemicals in our environment, in our lives, wouldn't it be easy just to get rid of all the hazardous compounds? Actually, that's not possible. It would be easy from a hazard perspective, but it's unlikely that will ever happen. Think about all the natural hazardous compounds which are around us, but also the ones which we need for our economy, higher crop yields, thorough control, but also think about building houses. Like I said in the morning, toothpaste is a hazardous substance and shampoo is a hazardous substance. And personally, I really enjoy using them. So we need to consider all the risks and all the benefits of substances. So how does the process work? We start with an applicant which comes in and asks us, can I import or manufacture this substance? So the EPA is not chasing people like we want to have this substance in New Zealand. They come to us. So they send in an application and we start working. The first thing what we do is classify a substance. I will explain later what all these things mean, so this is just an overview of the process. So we classify the substance, and based on the classification we get some prescribed controls, which are basically triggered automatically. Then we do a risk assessment in which we are going to look at exposure. And thereafter we weigh the benefits and the risks and see whether the benefits outweigh the risks or whether the risks outweigh the benefits. And we write this all up and send an advice to our decision makers. So we start with classifying the substance and we look at the hazard of the substance, which basically means if you have the pure substance and you pour it over your hand, is it going to burn a hole? That's one of the classifications we're looking at. But there are many, many more. So we have human health classifications. There are classifications looking at something. Is it likely to explode? But we also look at classifications for the environment. So we look at the risks to the aquatic environment. we look at the risk to soil organisms, we look at the risk for terrestrial vertebrates like birds and terrestrial invertebrates like bees. So if we have these classifications, like I explained before, certain controls are already triggered. And controls are basically rules what you can and can't do with a substance. So there are several types of controls. For example, our packaging. We want to keep the substance in the packaging, and if it's really harmful, we want to make sure that our children can't get in, can't get into it. So we have rules around that. Identification, what do you have to put on the label? Do you have to provide, which information do you have to provide in your safety data sheet? Disposal, can you chuck it through the drain, or do you have to bring it to a special disposal site? Emergency management, if you want to use the substance, do you need to have certain things in place? And probably from an exposure perspective, the use controls are most relevant. So if you use any hazardous substance around your beehive, make sure that you know what kind of controls apply. It's important for your own safety and also for the safety of the rest of the environment. So I want to focus on one of the type of the controls, which is the use control, because we have a control which is specified to protect terrestrial invertebrates, and particularly bees, because most of the information we get to determine whether this classification applies comes actually from toxicity to bees. So one of our controls is that a person cannot apply a substance with this classification if bees are foraging in the area, if the plant is likely to be visited by bees, if the plant or tree is in open flower or part bloom, or is likely to bloom within a particular period of time. We know that there were some kind of hitchbacks in the current regulations, so we're improving this control, and we hopefully it will be signed off by the board soon, so it will be even tighter, so the controls will be even more protective. So this will be a slightly complicated slide, so please bear with me. And if you have any questions, please come and see me later in the science corner. But only looking at the hazard is not the whole story, because there might be a hazard, but if there's no exposure, there's no risk. So I'm trying to explain how we assess that in our risk assessment. So if we look at the top row of bees, can you see my mouse? I'm sorry, my mouse is not coming up. Oh, there it is. If we look at the top row, we see that we look at the different glasses, and the glasses are actually a way of explaining how much the bee needs to be harmed. So think, for example, about, we all know the effects of alcohol. If you just drink a little bit, you don't notice it. So that's basically up to the third glass, you're okay. But as soon as you drink much, much more, you're harmed. So the safe concentration of, for example, for alcohol is up to the third glass. Now we have another type of substance of which the safe concentration only goes up to the first glass. So you can only have a little bit of this substance before you're actually harmed. So this is the way we look at toxicity. Toxicity is based on lab studies, which can be acute studies with bees, can be longer term studies, but are also based on semi-field studies in which bees are exposed to a crop which is sprayed with a substance in a tunnel scenario, and can be longer term studies in which the bees are actually released to the field and you get a more real-time idea what's happening. We can look at acute effects, so in that case the crosses would be 50% of the population is harmed, or we can look at chronic effects in which we, for example, look at reproduction. So we look at the most sensitive endpoint during our risk assessment, so we pick the one which is basically harming the bees at the lowest concentration. But like I explained, toxicity is not the whole story. We have to look at what actually is the bee encountering in the field, because then we can make a choice whether there is actually a risk or not. If we, for example, look at product X, which is the top bar, it seems to be less toxic than product Y, but the efficacy of product X is lower than the efficacy of product Y. And this information is what we get from our applicants. They tell us which rate of the substance they need to protect the crops. So for product X, if I run my models to estimate the exposure to the bees, I end up in the last full glass, which means that it's not safe for bees because only the third glass is safe. Product Y has a very high potency for the target pest, and we only need a little bit of the substance. So in the end, if I run my models, I only have the amount which the bee will encounter in the field, which is the first glass, which will be a safe concentration for the bees. So that's how we weigh the toxicity and the exposure to see if there's a problem. If we identify a problem, we can formulate additional controls to manage this problem. If we see that it's safe, we do not formulate additional controls. If we see that it's unsafe, even after we added these additional controls, we consider that there is a risk and we will flag this risk to the decision maker. So this is the whole process in a nutshell. So an application comes in, we classify the substance, which will result in a bunch of prescribed controls. We do our risk assessment, which results in additional controls, and then we do our risk-benefit analysis and give our advice to the decision makers. We believe that this process will help us to give robust and evidence-based advice to our decision maker, which is based on science, risk analysis, judgment, and experience. Sometimes the data is poor, and in that case we have to weigh the benefits, but also consider the potential risks which might be resulting in this unknown risk. Especially our precautionary approach has a lot of critics, especially in the industry, who would like to get their products on the market. There will always be parties which will be pleased by our decisions and parties which are disappointed by our advice. Like, not everybody will always agree, and that's something which is the space of the regulator. So that was my talk about what's happening before a substance can hit the shelves. If it does, our work doesn't stop. We monitor the overseas developments and the overseas scientific developments. We talk with other regulators to ensure that we have all the information we need to formulate our policy. Besides looking overseas, because our aim is to protect the bees and the pollinators in New Zealand, not the bees and the pollinators in Europe. So we look at the reports which are published about bee health in New Zealand, and we have our pollinator incidence scheme, of which I really would like to ask your attention. Because this is a core of information. Please let us know if you have any weakened or lost hives, because we think you will have the best information. You have the information we need to monitor what's happened when a product has hit the market, if a substance is in the field. So our incident scheme is pesticide focused, and we need as much information as you can give us. So we're a science-driven organization, so unfortunately saying my neighbor sprayed X and my bees are harmed, it's not enough. We need all the information that we can make sure that that was the product which was used. That's the product which has harmed your bees. So what would be the ideal situation is if you could back up this information with analytical results. So please help us to inform our future decisions. So if you lost your hive, if you think there is a chemical involved, please tell us. You can go to the EPA website and search pollinator incident. You will find all the information you need, and there is a form which you can fill in. And please send it to the HS incident email. And I saw a lot of people taking pictures with photos, so with their camera. So please make a picture of this screen so you have the information or write it down. So with this request, I would like to finish up, and I will give the floor back to our chair. And if you have any additional questions, please come and see me at the Science Lounge. Thank you.
Thank you.